Did you know that many people believe the periodic table is flawless? It's easy to think, oh, that's just how chemistry works, while a more complex story brews beneath the surface. Let's dive into the troubling misconceptions surrounding how A classifies chemical elements on the periodic table. This is merely a scientific concern. It's a ticking time bomb that could reshape our understanding of the elements around us. Most of us view the periodic table as a straightforward, reliable reference. But what if I told you that artificial intelligence is shifting our perceptions in ways we might not even notice? The very foundation of chemistry is being questioned, often without our awareness. Imagine you were at a dinner party discussing the latest in A, and someone mentions how algorithms can classify elements better than humans. You nod along, but inside, you feel uneasy. What if those classifications are incorrect? What if A is leading us astray on something so fundamental? Let's take a closer look. Many people don't realize that A learns from existing data, which can be riddled with errors. So, when it comes to classifying elements, it's not just crunching numbers, it's learning from human mistakes. Imagine relying on a well-trained A for the right answer, only to discover it's based on outdated or inaccurate information. Could your understanding of chemistry be built on shaky ground? Consider this every time you pour a glass of water or take a deep breath. You are interacting with elements influenced by these classifications. What if an A misclassifies an element, leading to flawed research or even unsafe products? You trust that scientists know what they're doing, but they also depend on this technology. The stakes are higher than you might think. Scientists are racing against time to refine these classifications. The danger: misinformation can spread quickly, impacting everything from education to industry. You might unknowingly be part of a system that misinterprets the very building blocks of life. But don't lose hope just yet. Awareness is the first step toward change. By questioning what you hear and maintaining a healthy skepticism, you are already ahead of the game. Engaging in discussions can help steer the conversation back to accuracy. Before you dismiss this as just another science debate, consider the implications. Are you ready to take a closer look at what's really happening beneath the surface of the periodic table? As you ponder this, think about how often you accept information at face value. The next time you glance at the periodic table, remember not everything is set in stone, especially when A is involved. Stay curious, stay informed, and who knows? You might just become part of the solution. If you found this insightful, why not explore further? Your journey into the captivating world of science is just beginning. What if I told you that our classification of chemical elements is facing a serious challenge? It might sound surprising, but there's a growing misconception about artificial intelligence and the periodic table that you need to be aware of. Imagine walking into a lab, feeling confident about how elements interact. But what if that confidence is built on shaky ground? Many people don't realize how A is reshaping our understanding of these essential building blocks. Are these machines offering accurate insights, or are they steering us in the wrong direction? Let's dive deeper. We've relied on the periodic table for over a century, but A is shaking things up. Algorithms are analyzing elements in ways we never thought possible, claiming to reveal patterns that even the brightest minds have overlooked. Sounds impressive, right? But what if these patterns lead to dangerous misclassifications? Picture this: you're a chemistry student, depending on your textbooks for accurate information. Depending on your You're okay for accurate Suddenly you discover that A has misclassified an element, placing it in the wrong category. This could result in flawed experiments or even hazardous situations in the lab. The stakes are incredibly high, yet many people seem indifferent. Why is that? Consider a recent study where A misidentified a basic element, throwing the entire classification system into chaos. This isn't just a theoretical error, it could have serious real-world consequences. Imagine a pharmaceutical company basing their research on this incorrect data. Lives could be at risk. Now, let's talk about the growing divide in the scientific community. Some experts are excited about A's potential, while others warn of its dangers. This split is widening, leaving many people confused. People. Who should you trust when the stakes are so high? Before we can find solutions, we need to acknowledge the risks. The very foundation of chemistry is being questioned. As someone eager to learn, you must ask yourself, are you ready to navigate this uncertainty? So, what can you do? Stay informed. Question the information you receive, especially about something as fundamental as the periodic table. Don't let A shape your understanding without critically evaluating its authority. In this rapidly changing landscape, skepticism is your best ally. Think about how you approach scientific knowledge. The world of chemistry is dynamic, and your understanding should adapt too. As we wrap up, remember that the truth often lies beneath layers of complexity. Stay curious and don't let misconceptions cloud your judgment. The next time you look at the periodic table, take a moment to reflect. What might A be missing? Why A be missing? Technology is woven into our daily lives. Think about when you ordered groceries online or used X for directions. Now, imagine applying that same blind trust to something as critical as chemical classification. It's a ticking time bomb, and many people remain unaware of the risks involved. The stakes are high. Errors in classification can lead to dangerous chemical reactions, poorly manufactured products, and compromised safety regulations. You might be on the verge of a breakthrough, but a simple misclassification could derail everything. So, What's the way forward? We need to approach A with a critical mindset. Challenge the data, question the conclusions, and always double-check. Let's combine human intuition with machine learning. The elements in the periodic table deserve our careful attention, and we must advocate for accuracy. As you reflect on this, consider your role in a world increasingly shaped by A. Don't let misconceptions guide your actions. Stay curious, ask questions, and remember that knowledge is power. If you want to stay informed about these important issues, subscribe and join the conversation. Join the important sorry. I am for sorry your mystery your about you show you